Okay, let's dive into this. Picture this. It's March 2024. You're in the middle of a high-stakes cyber thriller, but instead of a spy, our protagonist is just a guy sitting in a normal chair in San Francisco staring at a terminal screen. Today, we're going to explore the absolutely wild, untold story of the software that quietly runs the entire world and how it literally and accidentally saved us from a global digital catastrophe.
Half a second, that's it. A software engineer named Andrew's friend noticed his SSH logins, those secure, behind-the-scenes connections to other computers, they were taking exactly 0.5 seconds longer than normal. Now, most of us, we'd probably just blame the Wi-Fi and go grab a coffee. But Andrews didn't ignore it. He ran a diagnostic tool and traced this microscopic delay to a compression library called XCUtils. And what he found hiding inside was chilling. A CVSS 10.0 backdoor. That is the maximum possible severity rating for a cyber threat, meticulously planted by a state-sponsored attack.
Security experts were completely freaked out. They called this potentially the most dangerous supply chain attack in the history of the internet. Think about that. The attackers spent 3 whole years using social engineering just to infiltrate a trusted open-source project. This backdoor was designed to hand over a master key to hundreds of millions of computers. And the truly terrifying part? It was just weeks away from shipping in stable releases of massive operating systems like Debian, Ubuntu, and Fedora. Literally weeks.
Now, what's really interesting about this is, who exactly is Andrew's friend? I mean, he isn't some elite cybersecurity operative for the NSA. He's a software engineer. And his day job involves working on a database that most people outside the tech bubble have probably never even heard of. It's called PostgreSQL.
But inside the tech world, oh man, PostgreSQL is absolutely everywhere. Instagram, run on it since day one. Spotify, Reddit, Apple, they all completely rely on it. It literally runs on the International Space Station, and it reliably processed 55 million data points a day for the UK's COVID-19 dashboard. In fact, if you look at the data, it's Stack Overflow's most loved and most wanted database on the planet, consistently crushing massive, multi-billion-dollar commercial competitors like Oracle, MySQL, and MongoDB. So how on earth did this invisible powerhouse come to be?
Section 1. An accidental academic prototype.
Let's trace this timeline way back to 1971. A 28-year-old assistant professor named Michael Stonebraker arrives at UC Berkeley. Now, his PhD was in Markov chains, which he freely admitted had absolutely no practical value whatsoever. And incredibly, he had never even built a piece of software in his life. But he had vision. He helped build this early database called Ingress. But when real-world customers started complaining that Ingress couldn't handle basic things like a 360-day financial calendar, he realized it was just too rigid. So, jumping to 1986, he started over with a radical new idea: make the database infinitely extensible. He called it PostgreSQL, literally post-Ingress. He directed this brilliant rotating cast of grad students to actually build the thing, and it was revolutionary. But then, in 1994, Stonebraker just left to start a company. The university released the final code and walked away. The project was totally abandoned.
And here is where fate steps in. The code was accidentally rescued by 2 grad students, Andrew Yu and Jolly Chen. Stonebraker later affectionately nicknamed them Grumpy and Sleepy. The funniest part is, they weren't even Postgres developers. They just needed a reliable database for their own research. So they cleaned up this abandoned code, added the standard SQL query language, trimmed the entire codebase down by 25%, and vastly improved its performance. Then, they released it as Postgres 95 in September 1995. The wild part? They didn't even want to maintain it. They just set up a mailing list, tossed it onto the early internet, and casually walked away.
Section 2. An unlikely band of misfits. So, with the academic creators completely out of the picture, who actually takes over? Well, a ragtag group of internet volunteers. Take Bruce Momjian. He wasn't some corporate database architect. He was a former high school math and computer science teacher. When he downloaded Postgres back in the late 90s, he realized this brilliant software was just desperately lacking leadership. So, he decided to step up. He became its public face, its evangelist, and lead organizer for the next 3 decades, keeping the whole project moving forward at a time when their main goal was literally just trying to stop the database from crashing. Then you have Tom Lane. Originally, this guy wanted to design pinball machines. Instead, he went on to build the libjpeg library. What does that mean? It means he helped write the code that processes almost every single JPEG image you have ever seen. Oh, and he also wrote code that runs on the Perseverance Mars rover. No big deal, right? He joined the PostgreSQL community simply because he needed a free database to store stock data. He got hooked and became one of its most legendary, witty engine builders.
We also have Vadim Mikhev, a developer from Krasnoyarsk, Russia. He contributed this thing called Multi-Version Concurrency Control, or MVCC. This was an absolutely massive architectural leap. Basically, it meant multiple users could read and write data at the exact same time without locking each other out. So you have this global, volunteer-led effort quietly piecing together a masterpiece, just one brilliant contribution at a time.
Section 3. Defeating the NoSQL hype.
Throughout the 2000s and 2010s, Postgres was facing some intense competition. MySQL was riding the Web 2.0 wave, and MongoDB was super loud about pushing the NoSQL revolution, basically telling everyone to abandon traditional database structures. And Postgres? Well, it did something deeply unfashionable. It just remained the boring database. It focused entirely on methodical correctness. But then, in 2014, a professional Russian astronomer named Oleg Bardatunev needed a flexible database to literally map the universe. So he built a feature called JSONB right into Postgres. Suddenly, this traditional, boring database could easily store flexible NoSQL documents while keeping all of its rock-solid reliability. In one fell swoop, an astronomer's code effectively ate MongoDB's lunch.
But it wasn't always smooth sailing. In 2016, Uber published this absolutely brutal blog post detailing why they were ditching Postgres. They severely criticized its write amplification and index bloat, which are essentially issues with how the database was inefficiently storing and updating massive amounts of data. It was a huge blow to the community's pride. But as experts pointed out, Uber was basically judging a 2024 car by a 2012 model standards based on their very specific workload. Still, rather than just getting defensive, the Postgres community used it as a massive rallying cry. They rolled up their sleeves and methodically fixed exactly what was broken.
And while Western startups were busy writing hit pieces, Japan had actually been quietly betting big on Postgres since 1991. Bruce Momjian called it the Jerry Lewis phenomenon, where something becomes inexplicably huge abroad. Heavy hitters over there like NTT and Fujitsu were pouring serious resources into it. In fact, that pivotal 2010 streaming replication feature that finally silenced the Western critics, it was built primarily by Japanese developers who had spent a decade demanding it.
Now, if there is one thing this brilliant community gets wrong, it is definitely marketing. Back in 1996, they renamed the project from Postgres to PostgreSQL. Tom Lane famously called this the single worst mistake this project ever made. It sparked decades of fierce debate. I mean, one developer even offered a $500 bounty out of his own pocket to change it back. They even have an official audio pronunciation file on their website that absolutely nobody listens to. But hey, despite the terrible name, the technology just kept winning.
Section 4. The elephant never forgets.
Over $10 billion. Michael Stonebraker, the original creator, eventually won a $1 million Turing Award and humbly called the massive success of his creation a happy accident. But guys, the commercial ecosystem that has sprung up around this volunteer-driven project is just staggering. Companies like Supabase, Neon, and Crunchy Data, not to mention the managed services by Amazon, Google, and Microsoft, have created an ecosystem worth well north of $10 billion. And all of it is built on code maintained by an independent community.
So how does a volunteer project stay this relevant for 40 whole years? Well, it all goes right back to Stonebraker's original 1986 vision, infinite extensibility. When the world needed complex mapping, the community built PostGIS. When NoSQL documents became popular, they added JSONB. And today, right smack in the middle of the artificial intelligence boom, they've seamlessly added PG Vector. The database just continually absorbs whatever crazy new paradigm the tech industry throws at it, and it does it without breaking a sweat.
So, the crucial point is, how does all of this connect back to where we started? Back to Andres Freund and that microscopic 0.5-second delay in March 2024? It connects entirely through culture. The very same culture of precision, patience, and obsessive correctness that sustained this boring database against 40 years of industry hype. That is exactly what saved the internet. Think about it. Only a developer steeped in a community that obsesses over microseconds and methodical perfection would notice a half-second anomaly, flat out refuse to ignore it, and unravel the most dangerous supply chain hack in history.
The boring database's culture of correctness turned out to be our ultimate superpower.
And yet, despite basically saving the digital world, the project remains delightfully human and deeply accidental. Even their famous elephant mascot is a total fluke. It was originally proposed because elephants can remember, which is perfect for a reliable database. But in 1999, a Russian designer sketched a logo and randomly saved the file as slonik.gif, which means little elephant in Russian. She just named files however she felt like. And the volunteers? They just rolled with it. Nobody bothered to change the file name, and boom, Slonik the elephant was officially born.
Which leaves us with this final, profound question to ponder. How did a happy accident save the modern internet? I mean, from a professor who couldn't code, to a pinball designer, an astronomer, a high school math teacher, and a developer who flat out refused to ignore a half-second delay, it really makes you wonder, what other vital, volunteer-run digital infrastructure is quietly holding our modern world together right now? Thanks for joining me on this explainer. Keep questioning, keep learning, and I'll catch you on the next one.